Hi there, I hope you're having a great day. Today in this video I'm going to be programming the weapon systems for my helicopter enemy. We'll start off by programming our script to know which way our helicopter is facing. And then we're going to program our rockets to home in on the player, take those rockets and make them spawn from the helicopter when the helicopter is forward facing. And we're going to add an explosion effect to the rocket for when its lifetime runs out or when it hits the player. And then we're going to move on to a side firing weapon system, which is just a turret on the side of my helicopter that constantly shoots out particle effects for the player to dodge while the turret moves back and forth. So if you like game dev content, please subscribe to the channel, and with that, onwards to the video. Our first script here, we have our helicopter's weapon script. This is going to determine which way we're facing and then which weapon system to fire depending on that. First thing we do is create a private enum weapon system with forward firing and side firing as our two options. You don't need to worry about this serialized field. First thing we're doing in start is determining our weapon system, and then we are initializing our weapon system. I haven't done any of the initializing weapon system code yet, so I'm just going to go into the determining weapon system code. To do that, we just look at our rotation. If our transform rotation is equal to quantonian identity, then we're using the forward firing weapon system. Else if we are equal to quantonian.euler minus 90 degree on the y-axis, then we're using the side firing system. Else something's gone wrong, I throw up a warning, and we default to the forward firing. With that, I'm going to go back into Unity and program in a homing missile. I've imported my rocket model into Unity and I've prefabbed it. What I'm going to focus on is getting the rocket to chase after the player. So we're going to create a new C# script called homing projectile. Okie dokie, let's magic some code. We have three variables here. We have our rocket speed, its rotate speed, and its lifetime. Speed will be how fast it's moving on the screen, rotate speed how fast it rotates, and lifetime how long until it destroys itself. We then have a private transform, which is going to be our target. When this object is created, we go into void start. We create a player variable of type GameObject using GameObject.findGameObject with tag player. This might break if I have multiple players, but that is a problem for later down the line. Player is found and it doesn't equal null. Then we set the target to be the player's transform. We then destroy the game object after lifetime seconds, which will just destroy our rocket, delete it from our game. Down in update, we check if target is null. If the target is null, we're going to send the rocket in a straight line from wherever it spawns. To do that, we just do transform.translate vector.forward times speed times time.delta speed. If we have got a target, we don't do this. We go and create a new vector3 direction, which is equal to target.position minus transform.position. We then take that and we normalize it using .normalize. We create a vector3 for rotate amount using equals vector3.cross, putting in the transform.forward and the direction. We tell the transform of our missile to rotate by the rotate amount times by rotate speed times by time.delta time. We tell it to move its position using transform.translate vector.forward times speed times time.delta time. What this will do, it will get the direction that we need to face, it will rotate in that direction and constantly send the rocket forward, so we're always rotating towards our target. Let's try it out. We stick that script onto our rocket prefab. We've got the speed at 10, rotate speed at 200 and lifetime to 5. Hit play. Yeah, it is definitely flying towards me. I'll just up the speed a little bit and up the lifetime and see what happens. Yep, that's definitely coming towards me. Oh, did a backflip and it went the other way. I guess it got confused. Now we've got a missile that flies towards the player. We're going to make it spawn on the front of the helicopter when it is facing forward. We're going to open up our helicopter prefab. Under our front weapons object, we're going to create a new empty. We're going to call this rocket spawn and position that where I want the rockets to appear. Now we want two of them, so I'm going to create a second one with Control D and move it into place. And that's all we need to do to the helicopter at the moment. I'm going to jump back into the helicopter weapons script and I'm going to do the logic for the rocket system. Okay, new variables added. We have three serialized fields, a private game object front rocket prefab. This is where we're going to put our rocket. Then we have an array of transforms for the spawn points because we're going to alternate between the two spawn points. You may not need a lot of this code if you are just doing a singular spawn point for your rocket. And the rocket fire rate, just how often we're going to fire off one of these rockets. We then have two other variables with a float for the cooldown and an integer for the current spawn index. In start, we now have rocket cooldown equal to rocket fire rate, so we can keep resetting back to it. And then down in update, we're using a switch statement. with two cases. In the case of weapon system being forward facing, we use the handle forward facing method, and in the case of weapon system being side firing, we handle the side firing method. Okay, so we run handle forward firing. If rocket cooldown is less than or equal to 0f, we fire the front rockets. Rocket cooldown equals rocket fire rate. Else, rocket cooldown minus equals time.delta time. This is just a timer that ticks down and then fires a rocket every single time rocket cooldown gets to 0 and then resets back to whatever it originally was using rocket fire rate. So what is fire front rocket doing? First of all, we check to make sure the front rocket prefab has been set and that there is actually spawn points in the spawn points. After that, we create a transform variable for the current spawn point, which equals rocket spawn point equals current spawn index. You won't need this if you're only creating one spawn point. This is because I have two. And we just double check one more time to make sure the current spawn point is not null. We then instantiate the front rocket prefab at the current spawn point dot position, at the current spawn point dot rotation, and then we set the current spawn index to equal current spawn index plus 1. We have a percentage symbol followed by rocket spawn points dot length. The percent operator returns the remainder of a division. We jump back into Unity, go to our helicopter prefab, and we're going to delete the prefab that is just floating there, and let's see if it works. Helicopter comes in, should shoot after a few seconds. Yep, there it is, there's the rocket. Nice, and we should get another one. Nice, we got one for both sides. The last thing I'll do to the rocket is create a small particle effect for when it explodes, either when it hits the player or when its lifetime runs out. We're going to go into our rocket prefab, and under our rocket we're going to create a new effect particle system and position that. I'll come back to you once I've made the particle effect. Okay, this is what I've come up with. I've come up with a nice kind of cubes just exploding, going from orange to red to black. I set the duration to 0.3 seconds, the lifetime to be between 0.5 and 1, the start speed to be between 3 and 6, the start size to be between 1.2 and 0.8, and I set the start color to be an orange. I've got play on awake off. We go down to emissions. I'm not doing any rate over the time or rate over distance. I'm just doing a burst of 15 with one cycle and interval of 0.010. For the shape, we just have a regular sphere. In color over lifetime, we have this gradient, which starts off this orange color, goes to a darker orange here, then goes to a red, and then goes to a black suddenly at the end. Down in the renderer, we're using a render mode mesh, and we're using the mesh of a cube. I also created explosion material. Right here, it's just a standard particle, standard unlit. I do want to turn emission on that and set that to orange, I think. A basic white material, because the color over lifetime is handling that. And then I haven't touched any of the other settings down here. And that creates this nice little cubic explosion looking thing here. Back to our scene. Now we need to go back into our homing projectile script to make it play that particle effect. Back in our homing projectile script, we have a new serialized field which is going to hold our explosion FX, and we have a private ball exploded which equals false by default. We have a coroutine called lifetime coroutine which is going to handle destroying the object when its lifetime reaches 0, and we start running that immediately in start. Down in the lifetime coroutine, we do yield return new wait for seconds lifetime, and then we are supposed to be running the explode method. So once the lifetime is up, it will just explode. On collision enter, if we haven't already exploded, we explode. So what do we do when we explode? If we've exploded, we return, we don't carry on this method. Otherwise, we set exploded to true. We check if we've got our explosion FX. We disable the mesh renderer of our rocket, so our rocket can't be seen anymore. And we run explosion FX.play, which plays our explosion. And then we run destroy game object, explosion.main duration, plus explosion.main.start lifetime.constraint. This will just make sure that when it gets destroyed, that the explosion has a chance to actually play and finish, because otherwise the game object would be destroyed and the particle system would get destroyed along with it, and we wouldn't see the entire explosion play out. So let's try it. We have a lifetime of 5 seconds, so after one spawns, we got 1, 2, 3, 4, 5 explosion, and if it hits me, also an explosion. That's what we like to see. I think I might have it so when the rocket gets destroyed, it breaks off into little pieces, and that there's another particle effect which has like the silver and the white. But that'll be for later. Now I'm going to focus on the side cannon, this weapon here. What I want that to do is when it comes down, just want it to rotate back and forth while shooting consistently, so the player has to fly around to dodge it while shooting the helicopter. Back into the helicopter weapon script we go. Right, for our side cannon gun, we have these 3 variables here, and these 2 variables here, and this variable here. We start with a private transform, which is our pivot point, which is where the rotation is going to take place on the turret. We then have the side rotation speed and a side rotation range. The range is to control how far it can go left and right. Speed is how fast. Private particle system array for side firing particle systems. This is because I have 2 cannons that I'm going to alternate between. You may have 3, 4, 5. The way I've done this, it should work with any amount. And we then have a float for the particle fire rate. And we have a private float for the rotation timer. We are using rocket cooldown in both the rocket fire rate and the particle fire rate, because this rocket cooldown is just a variable that's being used to reset back to the original timer that I've set. I'm going to show you a quick trick to rename variables. If you highlight a variable like this, press Ctrl R and then Ctrl R again, this box will pop up, and I'm going to rename it to weapon cooldown. Press enter, and then every single instance of that variable in this script gets renamed. We also want to put a switch statement in here. The way I had it originally was just setting weapon cooldown to rocket fire rate and then weapon cooldown to particle fire rate, which would just do nothing helpful. The way this is doing it with a switch system, we check which weapon system we're using and then set weapon cooldown to equal the appropriate fire rate. We go down to handle side firing, check that we've got a pivot point, and if not, we display a warning and return out of this. We have float angle, which equals mathf.pingpong. What pingpong does is it will go from 0 to whatever number you specify back and forth. This rotation timer times side rotation speed will control how fast we oscillate back and forth. Then we have our side rotation range times 2, which is our range of movement. And then we subtract side rotation range. This makes us center around 0 and oscillate between positive side rotation range and negative side rotation range. We then have a vector 3 for what our current local rotation is, which is our pivot point dot local rotation dot Euler angles. And then we have a quaternion for our target local rotation, which equals quaternion dot Euler, current local rotation on the X, angle, which is what we set up earlier, and current location rotation on the Z. From there, we just set pivot point dot local rotation to equal target local rotation, and we set the rotation timer to increment using plus equals time.teletime. If our weapons cooldown has reached 0, we'll fire our particle system and reset our weapon cooldown. Otherwise, we are just going to be decreasing the weapon cooldown, like with the rockets. When we fire our particle system, we check to make sure we actually have particle systems to fire, and then we just run side firing particle systems current spawn index.play, and then we increment that spawn index with current spawn index equals current spawn index plus 1, remainder of side firing particle systems.length. You may be wondering why we're not doing this in a while loop or something. It's because this is already in a loop in itself. It's in the update loop. Every time handle side firing goes off, this will eventually run and then increment to then fire the next side. The remainder side firing particle systems.length is just so that we go back and forth. When we reach the last particle system, we go back down to the first particle system. So if we jump back into Unity and we go over to our helicopter, I'm just going to use the turret's particle effect. I've put them into the turret barrels here. Right, so now we should just be able to jump into Unity and test this. Oh, there we go. It's straight away firing. It's kind of firing a bit far back, but that is what I'm looking for, that kind of thing. I'm not going to keep this particle system. I'm going to create a new particle system for this turret, but this shows that the system is working. What I want is the particles to maybe last for a little bit longer and fly out, and I have multiple of them. I'm going to create a new particle system, and I'll be back with you when I've done that. I duplicated the prefab from my bullet particles and I just modified it slightly to get the effect that I want. I adjusted the lifetime, the speed, the shape, and everything like that the same, the emission. I didn't really change much other than the speed and the lifetime of it. So go back in, and I've already hooked those up onto the helicopter. Okay, yeah, that is kind of getting the effect that I'm going for, having to dodge in between them. Although, because of the sway and tilt on the helicopter, that is causing the particles to go up and down a little bit, I think. Yeah, so they have quite a chance of missing the player. I think to fix that, I'm going to have to lock it on the x-axis so that they don't fly off up into the air like that. But that is getting the effect that I wanted to have, firing from both cannons out like that. If you have a turret on something that isn't swaying left and right like this code will work perfectly well. But that's the end of this video, because otherwise I could just keep going forever. This video is already long enough. If you enjoyed this, then please do subscribe if you're not subscribed already, and the like on the video would be greatly appreciated. If you have any suggestions for my game or any questions, I'd be more than happy to answer them in the comments below. And with that, Thank you for watching. I hope you have a great day.